All right, continuing where we left off, we just got done walking through the transformations in this exponential functions page. Again, talking about A, H, and K and how the beta value affects the graph. So now I'm just going to walk through one of the practice examples, just me talking through it. So one of them is from the notes we had before. Your homework's going to say graph the function, state the domain, the range, and the horizontal asymptote. So we're going to do a lot of the information here, and then we're going to graph it and plot it on this page. All right, so to start off with, we just want to figure out what is our transformations. So my H value is right here, which is going to be 1. So we're going to say H is equal to 1. And then the second value right here, this is going to be my K value. So my K value is going to equal -2. And sorry for all the clicks. So that means our H value is our horizontal asymptote. Our horizontal shifting is going to become 1, where our vertical shifting is going to become -2. And all of that is going to feed off of the parent function here, which is where I take all of the transformation stuff away. So looking at the values that we get for the parent function, when I just want to figure out what my graph looks like, if I plug -2 in, that's saying 2 to the -2nd power. So we flip the fraction, which has become 1 over 2 squared, so which is 1/4, so 0.25. And then we plug -1 in, that becomes 2 to the -1 power, so that's 1/2, so that's 0.5. And then anything to the 0 power, 2 to the 0 becomes 1. So there's my 1, there's my nice starting point. 2 to the first is then 2, and 2 squared then is 4. So currently, with my values, this would be my parent function. So I'm going to go to the next page. I'm going to graph those. I'm going to go 0, 1 as a point. And then we're going to go 1, 2 as a point. And we're going to go 2, 4 as a point. And then if we continue that, 2 to the 3rd power is 2, 8. Why is it disappearing? We'll go hieroglyphics. Sorry about this. Hieroglyphics will go red. So we had 0, 1. We had 1, 2, 2, 4, 3, 8. And then -1 we had a half. And then -2 we had 1, 4. So when it comes to graphing those fractions, just be as close as you possibly can. And then we're going to kind of just connect all of the dots using a nice smooth curve. So this is considered our parent function. So that is the function y equals 2 to the x power. It's going to be our parent function right now. And that's the one that you see right here. So if we go back and we have the h value of 1 and the k value of -2, that means I'm going to take this whole parent function and I'm going to shift the x values over 1 and the y values down 2. So I'm going to take this ordered pair -2, I'm going to add 1 to it, so it's going to turn into -1, and I'm going to take 1/4 and I'm going to subtract 2 to it, so it becomes 1 3/4. So otherwise I'm going to start here by plugging 0 in. 0, 1, I'm going to move this to become 1 over 2. So in the given function, if I plug 0 in, 0 minus -1 is -1. 2 to the -1 is a half. A half minus 2 is -1.5. We plug 1 in. 1 minus 1 is 0. 2 to the 0 power is 1. 1 minus 2 is -1. Plug 2 in. 2 minus 1 is 1. 2 minus 2 then is 0. So as we can see, the graph is increasing. And if we go beyond this, let's just change, and then we go, I don't know, let's add another row here. Let's say we go 3. We know 3 was 8, so 3 minus 1 is 2. 2 squared is 4. 4 minus 2 is then 2. So as we can see, the graph is increasing. And then negative 1 is negative 2. Negative 1 minus negative 1 is negative 2, so it becomes 1/4 minus 2, which is then negative 1.75. And as we were to continue, this is going to get closer and closer to our horizontal asymptote, and this is going to get farther and farther up. So we're going to go to the next page, and we're going to plot. I don't like to do tables for plotting, so your tables is always going to be like your safety net. Just plug chug numbers in, see what you get out. I like to take the transformations of 1 and negative 2. So let's grab my pen here. I'm going to take the point, I'm going to take this point, I'm going to go over 1, down 2. So my new point. I'm going to go over 1, down 2. I'm going to take the point right here, I'm going to go over 1, down 2. Go over 1, so it's become 4, down 2, and it's going to become 6. And then my point that was at negative 1.5 is now going to become 0, down 1, down 2, which will become negative 1.5. And then the point negative 2, negative 1/4 will now become negative 1, down 1/2. So my graph now is going to come in like this, doing an exponential growth. Sorry, I didn't connect the points there. That is equal to y equals 2 to the x minus 1 minus 2. Because we went right 1 and down 2. So there was my transformations that I performed from the parent function on each point. So notice 0, 1 just got shifted down 1/2. So there's no dilation value, there's no multiplication. So when it comes down to answering those questions, you can read it off of the function or you can read it off the graph. So in this case, my domain value, is there any x values we're not allowed to plug in? So we're looking at the x-axis. Are we getting values out? Yes. So therefore, we can say negative infinity to infinity is my domain. Or my range, looking at the given function, what is the lowest this graph can possibly go? Is this is going to get closer and closer to negative 2. And notice, look where that negative 2 comes from. It's our k value. It's our k value. It's the fact that we're shifting down. And then seeing it visually, we can see that the graph is never going to cross the horizontal asymptote of negative 2. So therefore my range value would be from negative 2, comma, in parentheses. And if you don't want to use this notation, that's perfectly fine. This is where you'll be using in pre-calc. The parentheses mean that it approaches, but it never actually hits. Or a bracket means it's a solid dot, it will hit it. Otherwise, if you go y values are greater than negative 2, so you go range, set notation, y values greater than negative 2, it's the same thing. We will accept both of those on that graph. So you can answer these questions from the graph, or you can answer these questions from the function. So that's me walking through the problem from graphing your parent function, applying and then plugging in values to get ordered pairs, and then just plotting the dots or doing the transformation from the parent function. Another way to do this is kind of to ignore the parent, not really ignore the parent function, just get to know how fast your graph goes really well. So I'm going to walk through the next example. So here now I know a value is going to be 3. So I've now increased my graph, and I'm going to put a little y change. I know my y value is going to change in this graph 3 times as much. Notice I kept the same parent function. And then the negative 4 is telling me that I'm going down 4 units. So plug and chug, we can still do that, and I'm going to kind of show that at the end. But I'm going to show you where I like to start with this. In some cases, if you're really grasping this material and you're looking for a lot of efficiency, I know that this is my horizontal asymptote. So I am going to go down here at negative 4, and I'm going to draw my horizontal asymptote. and -4. So I start there. And then I know because my B value is greater than 1, I have a growth. So in my head, I know this graph has got to be increasing from left to right at a base of 2. And since the first starting point for these first two ones are going to be 0, 1, and 1, 2 of the parent function, and 2, 4, I just memorize those three every time. So as soon as I know it's a growth, I look at the B value. The B value is 2. So because the B value 2 is 2, I know it's 1, 2, 4. I'm just going to keep squaring that value. 2 to the 0 power is 1, 2 to the first power is 2, 2 to the second power is 4. And then from there, I'm going to do the transformation. I'm going to move this point down 1, 2, 3, 4, down 1, 2, 3, 4, down 1, 2, 3, 4. That's what it would be is if we absolutely did not have any transformation, any dilation value. But now that I have a dilation value, I'm no longer at 0, 1. This distance is at 1 unit away. It's now going to be 3 units away from my horizontal asymptote. So this is going to be 3 units away from horizontal asymptote. So I'm going to go down 1, 2, 3, 4. But instead of putting that dot right here at 0, -4, I'm going to put that dot at 0, -1 because I'm 1, 2, 3 units away from our horizontal asymptote. So my new starting point should be 0, -1. And we're going to check that on the table over here in just a minute. And then this point, this distance is normally 2. 2 times 3 is 6. So I'm going to count up 6 units from here. 1, 2, 3, 4, 5, 6. So my first point, my second point, and then this distance is 4. So 4 times 3 is 12. So I'm going to count up 12 units from here, and that's going to land up here at 8. So we're going to put a dot at 8. So instead of my parent function looking like this, now my graph, and if I went -1, go a half. Half of 3 is 1.5. So I'm going to go up 1.5 units. So my graph is going to kind of come in looking like that. So notice I did my dilation value. This distance now became 3. My horizontal asymptote was my vertical change. So I didn't have to worry about moving those dots down. I just did everything based off the horizontal asymptote. And if we were to plug in values, if we were to plug -1 in, 2 to -1 becomes a half. Half times 3 is 1.5. 1.5 minus 4 is -2.5. And notice where the dot is. When we plug 0 in, 2 0 is 1. Times 3 is 3. 3 minus 4 is -1. And notice where our dot is, 0, -1. When you plug 1 in, 2 to the first is 2. 2 times 3 is 6. 6 minus 4 is 2. And notice where our dot is again. And last one, 2 squared is 4. 4 times 3 is 12. 12 minus 4 is 8. Again, notice where our dot is. So my horizontal asymptote has turned out to be really nice. So my horizontal asymptote is y equals -4. My domain is all real numbers. Whoa, what happened here? My domain is going to be all real numbers. So you got y equals -4. Domain is going to be all real numbers because we can't restrict, which means my asymptote is going to be -4, comma, to positive infinity. So again, like I was saying, please feel free to ask any questions. I know that seemed a little rushed. The dilation value should always do first, but sometimes doing it from the horizontal asymptote really does save time for everything. But get comfortable with either one. Pick and choose your choice. So thank you. I'll talk to you guys again later.